Hi, everyone. My name's Eric. I'm the co-executive director at Cal Poly.
And I'm Ethan. I'm the director of tech here at Cal Poly.
And today we will be showing everyone an intro to Git. And our presentation is called Getting Started in Intro to Git. And yeah, we will be taking you through the basics of Git, as well as trying to show maybe some stuff that people don't know. So we'll go ahead and get started. Cool. So before we start, I'm just going to talk about an overview of our presentation. So we'll start off with installing Git and creating a GitHub account if you don't have those already. We'll talk about what is Git, and then we'll delve into some more core Git concepts like commits, repos, branches. We'll talk about collaborating on teams and what that kind of looks like, what's used, the difference between Git and GitHub, as well as some general Git etiquette, and going backwards in your code with Git resets. And we will end our presentation with a demo. And to start off, this is just a quick check if you have Git, but you can just in your terminal run git -- version just to check if you have it. And if you don't have a Git version showing up, you can install Git for your operating system at one of the links shown here. So definitely do that on your own time. And then also create a GitHub account. It's where you store all your Git repositories online. There's other places like GitLab, but in my opinion, GitHub is where it's at. And so, yeah. And to start off, so what is Git? Git was created in 2005 by Linus Torvalds, the creator of Linux. And he was using it as a tool for Linux kernel development. Git is a distributed version control tool. And so what does that mean? And what is version control history? It's a system that keeps track of changes to a file or a directory of files over time. So you can refer to specific versions later. It's great for collaborating on large development teams where you're working on a large project. It allows you to track down what changes were made and when. And also it allows you to revert back to a previous working state of code if you, say, needed to go back. And Git is a local tool. You don't need internet access to use Git. It can just work on your local machine. And you can connect to, say, a remote server with internet access by doing Git Push and a Git Pull. Also, what is Git Model after? It's a directed acyclic graph, and where the commits are nodes, and each commit points backwards in time to a previous commit. That way it can reference its parent and therefore its history. And so, yeah.
Yeah, awesome. So now we're going to talk a bit about like what Git actually is. So Git is really built off of things called snapshots. And just like a picture, these kind of track like what's going on. You take a picture, that's how things are. So it records the state of things at a certain time. And you're the photographer in this analogy. So you get to decide what to take a picture of and kind of when. So actually taking a snapshot is called making a commit or committing. And it does a little more than just take a snapshot. So it does do the snapshot, but it also tracks who made it. It references the previous commit. That's kind of how we get that acyclic directed graph. And it also comes up with a hash name. So a collection of commits is what makes up a repository. It's basically the series of commits from the very start all the way to wherever the project is at a given time. And kind of like a photo album, or this would kind of be like a photo album if commits are the photos. You can look through it. Pretty cool stuff. So actually getting ready for commitment or committing files, first you have to stage them. And this is done through git add, which takes files from your working directory and puts them into the stage directory. And that's basically telling Git like, hey, I'm about to commit these. So once you've staged all your files, then you actually commit them and it's history from there.
I'm down to surf this weekend.
So we also have branches, and all commits kind of live on a branch. At the very start, this is just the main branch, but like a tree, you can start at the trunk and branch off of it. And in that tree analogy, it's kind of like the commits would be leaves. So the structure of Git, it's really designed to make branching super easy. It's something we'll want to take advantage of, and we'll talk about like how we can do this a bit later. And in this picture, we start on the main branch, and like I would decide, hey, I want this super cool feature. I'd branch off. My work's in blue. Someone commits to the main branch. That happens. The orange person's like, oh shoot, here's a bug fix. Let me branch off, fix that. And all of that eventually gets merged together. So checking out is really about jumping around your code. This can be between branches as well as the history of your actual repository. So switching branches is something super useful for multitaskers. Like if you want to work on a feature, this feature, you do it in this branch, another one up here. It lets you jump around without mixing all those changes together. And you can also jump back in time, which gets super useful if all of a sudden you have a bug. You can't really figure out why, but you could try and find it by jumping around through your code. And in both cases, checking out a commit or another branch actually replaces the code in your working directory, letting you see like the repo at that state in time. So with branching, you may have noticed like, oh, tree branches, they don't really come back together. That's where that analogy kind of breaks down, but we're able to merge it with Git. So it's putting our code back together. This is done by hopping onto the branch you want to merge into and then saying git merge that branch. And some of the times it'll work perfectly fine, no conflicts. But other times you might have like tweaked code in the same spot and Git's like, oh shoot, something happened, we got to fix this. But Git actually doesn't know like how to fix it all the time. So it says, hey, you're the developer here, you really know what's up, and it gives you kind of something looking like the thing on the right side. You can see like there's head, green text, an equals line, to do, and master line. So that's kind of saying, hey, this code on top is in the thing you're trying to merge from. The code on bottom was already here. It's up to you to figure out how to fix that. And you would delete the lines you don't want, keep the ones you do. And that's basically how to resolve a merge conflict. So Git's super powerful on its own, but it's also really useful for collaboration. So Git versus GitHub, it's like these sound super similar, but you can kind of think of it like porn and Pornhub. Like you have the content, but it's not really the same. One hosts the, like repos, I guess. So yeah, Git's the actual control tool. GitHub hosts it all. GitHub's actually huge too, over 100 million repositories, just all out there. And it really adds to Git. Lots of features, as you can see, like issues, pull requests, even GitHub Actions, which is like free computing, project documentation, and a lot more. So with working with a remote server, you'll have to keep up to date with the current code. And that's kind of up to us to do. And we'll do that by pushing and pulling to GitHub. So pushing sends your local commits and changes up to the cloud, and GitHub deals with that. And when other people make pushes, you might have to pull it to keep your code base up to date, and you would do that with a git pull. So working on a team, this is like really why we learn Git. It's really nice as is, but there's certain etiquette we want to follow, just so all our code stays clean, workflows are nice, and this kind of comes into play with cloning, commits, and branches. So to start working on a project, you have to actually clone all the entire repository from the remote server. This could be done directly from the repo, which would just make an exact copy of everything on the server, or you could fork it, which what that does is it makes a virtual copy of the repo, and then you clone your virtual or remote copy. And that's definitely the most common practice for large open source projects, but directly cloning from a single repo usually works pretty well when working on small teams. And regardless of like forking or not, you'll still have to clone from a remote server onto your local machine. So commit etiquette. Commits are really how we track progress of the project. So we want these commit messages to just be super descriptive, make a lot of sense. And we can do that by using descriptive messages, explaining what applying the commit does. So like this commit would add the ability for mobile login. Like that'd be a commit message example. We also want to keep our commits really small or just focused on a certain feature. So we wouldn't want to mix like that mobile login with typo changes, with CSS fixes. Like, no, this should all be separate. That way someone else can easily see like this did that, that did this, and so on. And that also allows for having those small commits allows for quicker development. Since you're making commits, you're pushing them up. And when someone is pulling those commits down, there's just less chance for a merge conflict to occur. And then with branches, we really use these just because they're super easy to create. So we want to take advantage of them. The main purpose is to keep the main branch clean from clutter. We don't want a ton of tiny commits littering our main branch. So we would create a branch if we wanted to say like add a feature or experiment with like, hey, what if we did something this way? Or even things like fixing a bug. I mean, Git makes it easy enough to just make a branch. So usually we'll do it for like really whatever kind of change we want to make. And naming conventions for the branch kind of vary between teams. There's not like a definite answer to how to do this, but there's an example on the slides. Like you could say what type of branch it is and then what it's for. And that just kind of keeps everything pretty organized.
Yeah, so I just want to touch on where code kind of lives when you're using Git. Ethan kind of talked about these areas earlier, but I just wanted to talk about them more in depth because they are pretty important. But as far as Git is concerned, code can only live in 3 places. That is your working directory, the staging area, and history. So the working directory, that's just basically where your code base is, and that's where the .git directory will be located. The staging area, you can kind of think about this as your commit shopping cart. Like why do we need, I guess, an intermediary step between working directory and history? It's because, we want to actually see like what commits we want to theoretically like buy and, purchase, to use that analogy. History is where, the commits actually live, and that's where commits are made. And whenever you're doing, your typical workflow of git add and git commit, that's going kind of forward, right? You do a git add, git commit, git push. And that's what developers are used to that have, kind of just a basic knowledge of Git. The going backwards is where it gets a little bit tricky because going from history, say like you committed something, and going back to, putting that in the staging area or putting that back into your working directory, that can be pretty, I guess, complicated. And that's where resets come in. So Git reset, there's 3 different ways you can do it. By default, if you just did git reset file name, you didn't specify a flag. And the flags are just --soft, --mixed, or --hard. If you don't specify one, by default, it'll use --mixed. And what that will do, it will undo a commit from history and put all your changes in the working directory. And so the different ones, so doing a git reset dash dash soft, say you undo a commit, and then those changes from that commit are already staged in your staging area. And this will all make sense when I go into the demo, because I'll be showing kind of this kind of stuff. Git reset dash dash hard, that's probably the most extreme reset that you can do, because it'll undo the commit, but it'll actually just trash those changes. So you don't actually get the changes or any of the work that you did in that commit. It'll just go into the trash. Yeah, and so this next slide is going to be a joke courtesy of Sarah Ford. If any of you had the chance of having her for like 307, but she had this analogy of git reset dash dash hard 2020. Wouldn't it be great if we could do this with this year and just, trash all the changes made thus far and go back to January 1st, 2020. That's a bad joke, and I'll continue on from there. So we will go into the demo. So let's see how I can do this. Cool. So you can follow along if you want, but if you don't want to follow along, that's fine too. I just have a directory here called git demo, and it's, don't pay attention to that. It's not what we're going to be using, but let's go ahead and create a new directory called, what should we call it? Demo 1. CD into demo 1. Okay, so this is an empty directory. We want to start adding Git. You don't always have to clone from GitHub in order to start using Git. You can actually just initialize your own Git repository inside of here. And the way you see that is by doing an ls-a. You can see that .git is there. And .git is a directory. It's not a file. So if we wanted to see what is inside of .git, this is what's inside of .git. I'm not going to bother explaining each of these because that's a little bit more advanced. There's a lot of things that have to do with blobs and hashing that I'm not going to go into for the sake of this intro tutorial. But yeah, so right now I'm going to demonstrate two different kinds of commits that you can have when working with multiple branches. I'm going to go through a fast forward commit, and that is where you essentially are adding commits on one branch, switch over to a different branch, add some commits, and then you go back to the initial branch and you just merge the thing in. You typically don't have any conflicts in that scenario. But then I will do another scenario where it'll be a merge commit. So you have commits happening on both branches, and then you need to basically merge one of the branches into the other. And it'll look a little bit different, especially in the graph. So to start off, let's go do the fast forward. So I'll start by making a couple files and adding them. So once they're kind of added, you can see that their current file 1 is in staging. So we commit this. So now we can see if we do a git log, which git log, that'll show you your history of commits. Dash dash one line dash dash graph. You can kind of see what's happened. So it's not a lot. So I'm going to add some more commits here. And I'm just doing this for the sake of example, but now we can see that we have three commits in the master branch. So let's say we want to implement a feature. We would do this by checking out to a different branch. And so here we could do a git checkout -b, and we'll call it feature. And the -b flag, that just specifies that this is a new branch and we want to immediately check out to it. You could accomplish the same thing by doing git branch feature that creates a new branch called feature, and then doing git checkout feature. But this is just combining those two things into one. So now we are in the feature branch. So we will go ahead and add some theoretical features. So all touching does, by the way, is just it's creating the file and not adding anything to it. So these are just blank files for now.
How did you get feature to show up next to demo 1 on the left of your $sign?
Yeah, so that's I believe this is in my .vim.rc or in my .bash .rc, but I can try to find it and send you a link to it. There's some pretty cool things you can do with your terminal in terms of how it shows up. Like another thing you can probably notice is that I don't have a whole path here. It just shows the current directory. So I'll definitely share that at the end.
Sweet.
Yeah, but thank you for bringing that up. And if anyone else has questions, please feel free to speak up or just say it in the chat.
How do we, so like if we say we like add something, but we forget like what we had added, and like before we hit commit, like the stage before, like in between adding and committing, is there a command that'll allow us to like see what's like to be committed, like what we have so far? Git status. Oh, okay, I see Finley just typed that.
Yeah. Git status will always tell you what's happening. And for example, I'll just do it right here, actually. Oh, actually, let's do git log one line first. This is so you can see all your commits. So essentially what we have here, we can see that there's 3 commits on the master branch and there's 2 commits on the feature branch. But yeah, git status, we can see that there's no changes. So it's going to say empty. It's going to be clean. And right now we're going to show you the fast forward commit. So if we just check out back to master and let's add one more, I guess, commit and master. So right now it's just a bunch of commits, nothing really special going on. Okay, so let's see what we have here. So you can see that master has no knowledge of the commits that were made in the feature branch because it's a different branch. But say we wanted to merge the features back into master, we would accomplish this by doing git merge feature from master. So just make sure whenever you're merging one branch into another, the branch that you want to merge into your current branch, just like be inside the one that you want to be in later on, I guess, if that helps. Oh, interesting. Okay. This actually may be the merge commit. Oh, okay. Yeah, this is the merge commit. Sorry about that. But so whenever you do a merge commit, different computers will handle this differently. Sometimes it'll just open in Vim. Other times you can specify you want to open in VS Code. But all you have to do here is write a merge commit message. So merging feature to master and save it. And then you can just close out of it. Cool. And now, so that was a merge commit. And now if we look at the graph, we can see that there's this cool thing happening where we actually have 2 branches going out and coming back together. And that's what a merge commit is. Yeah, essentially what a fast forward commit is, if I didn't do that last commit, adding file 4 when I went back into master, then if I merged, it would just be a straight line. And then it's that's a fast forward commit. And the reason why it's called a fast forward commit is because instead of having this thing where you have 2 branches coming together, all master needs to do is just like go straight ahead because there's no 2 branches, I guess. But yeah.
So that's so add feature 2 is where we made our feature branch, and then on that feature branch we created feature 1 and file 4, and then we merged all of that back into master, and now it's all together on the main branch.
Yeah, so where we created feature, we actually did it right before we did feature 1. And so we created feature, we added feature 1, we added feature 2, and then we went back into master. And so if we merged right there at that point, then that's just a fast forward commit. You wouldn't have like Visual Studio Code opening up. But then instead of doing that, we added file 4. And so that's, now we have like 2 different branches that we kind of have to put together.
Right. Okay.
Yeah. So great. So let's, I don't think, here, let me see if I can hide that. Cool. Cool. So now what I'll actually be showing you is an example of forking your code. So basically what people in Cal Poly Bootcamp are doing for Bootcamp, you should be making a fork, not a clone. You'll make a fork, then a clone of this initial repository, Bootcamp grocery prep. And so for this, I'm going to cd out of this. Let's go here. So, and what you're going to want to do, instead of going here to immediately clone, you want to go and fork the repo to your own account. So this is what that looks like. You can see that it's your name and then Bootcamp grocery prep, not Hack4impact Cal Poly Bootcamp grocery prep. And to get this onto your local machine, you can go ahead and do a Git clone. Just copy it over. So to start off, say, you're making changes, Bootcamp. And it already comes, with some Git tracking. And so say you're making changes in your fork of Bootcamp grocery prep, but there's been a bunch of changes. Maybe some pull requests were merged into the main repository. So back in here, so I'll go back to the original one. So for the sake of the argument, changes were made here, and I'll do that actually. So I'll just add my name. I'll get rid of this later, so don't bother pulling this and commit those changes. Yep. So now whatever changes that we made, maybe in README, would have a merge conflict if we tried to make a pull request and merge into this code base. So essentially what you want to do in order to avoid a merge conflict is pull, like Ethan said earlier. You want to pull from this repo. Now, how can you, from one repo, your own fork, pull from another repo? And that's where this concept of remotes come in. So if you run git remote -v, you can see your current remote, and that is by default called origin. And so that refers to the repository that this code base kind of like refers to on GitHub. And so you can make multiple remotes. So say you are deploying to Heroku, like you can make a Heroku remote. For our purposes, we're going to make an upstream remote, and it's called upstream because that's like, I guess the concept is that it's this like master repository that this repository is only a fork of. And so in order to set, git remote add, you can run this command git remote add, and this is probably what you will all want to do that are in the Cal Poly Bootcamp, is do a git remote add, and then the link. So you just take this link, git remote add upstream, specify the name. Cool. So now if we do git remote -v again, we can see that we have 2 remotes, one referencing origin and then another referencing upstream. And so right now, if I showed you README, we obviously don't have my name in there because we didn't pull the changes yet. Sorry, that's showing up. But if we just do a git pull upstream master, remember this command because you're going to probably use it frequently. Oh, wait. Oh, it's main. Yeah. So GitHub doesn't use the word master anymore. They changed it to main. So just remember that from now on. it happens a lot where you get the two words mixed up. And so now we are able to pull from another repo, essentially. So we look inside our README, it shows the name. So we pulled that. Okay. So that was that. Now, let's say this is the other thing you're going to do. You're going to make your own website, essentially. I'm not going to make a website in 5 minutes. Instead, I'm just going to maybe make some more changes to the README just for the sake of this tutorial. Ethan Zimbelman, I'll just add his name. Okay, great. So we added our changes. We do a git status. We can see that there's been changes. It's in the working directory. So we want to add them in order to get to staging. So we just add it, git add readme. We're going to get status again. We have it in the staging area. We can add a commit. Cool. So now if we do a git push origin master, because origin refers to our fork. Oh, not master, sorry. So this will push to our fork. It's not going to push to this link, but you can see the changes will be reflected here. So now we have both of our names. And so now if you wanted to say, make an open source contribution or just, have these changes be reflected in the original code base, what you would do is you see this right here. This branch is one commit ahead of Hack4impact Cal Poly main. This is kind of a shortcut. You could just go to pull request right here. Actually, I'll go back because this is just easy. And so you can see if I make this bigger, that the changes made in my fork will be going into the changes made in the base repository. And so we can create this pull request now. And pull requests, so it shouldn't just be the name of the commit. Pull requests can include like 10 or like 50 commits. Don't do a 50 commit pull request, by the way. It should just be like four to 8 maybe. But there's etiquette behind pull requests that I don't have the time to go over, but I will reference, I have a link to an article written by our National Director of Engineering, Ben Holmes. He made a really great article about pull request etiquette, and that'll be shown at the end of the slides. But for now, like just pretend that I have a really good pull request, great description, just top of the line pull request. You can then press create pull request, and then they should be able to merge. Yep. And then I have this button. I don't think you all will have this ability to do this. I'm like an owner on this account. So I have the ability to merge it because it's mergeable. But usually what will happen then is you'll request a code review. So you can go here, assign someone to review your pull request, see if it works. So I'll just request Elena and Ethan. And yeah, they can leave comments.
Tab, actually. Oh, sorry.
Oh, go ahead.
You hit the assign button. It's actually the reviewers tab on the top.
Oh, yeah. Sorry about that.
It'll actually suggest people to review your code. If you were editing code that someone else wrote, it would say, hey, that person wrote this code originally. They should probably review your changes. So just go with the suggestion most of the time. But,
okay.
Yeah.
Oh, yeah. Sorry. Yeah. Reviewers was right on top. Ben, I didn't even know you were here.
Like a ghost.
Cool. Yeah. So reviewers go there. Sorry, not assignees. So thank you for that, Ben. And yeah, so then from there, you can merge your pull request. This is an awful pull request, so I'm not going to merge it, but pull requests live here. We can already see that Cole Perry, one of our Cal Poly software developers, has already made a pull request with his grocery site. I'm not going to go into it, but yeah, it's great. So this is where for your first bootcamp kind of assignment, where you're kind of making your initial grocery site, you will do the process of making a fork, cloning that fork, adding your changes, and then coming up in here and making a pull request. But yeah, I hope that makes sense. And I think that's it for the demo. Does anyone have any questions before we go back to the slides? Okay. Cool. So like I said, recommended reading right here, plugging Ben Holmes' article. Let me get rid of this. And here you can just see, we'll share the slides after, so you don't have to type this link. The slides will be shared after this, so you can just click this link. But it basically talks about best Git and GitHub practices for teams, and it's opinionated. So yeah, and then sources, we have all of our sources that we used in the speaker notes. And like I said, we'll be sharing these slides so you guys can all have access to those. But yeah, I think that is it for our presentation.
Hey, Eric, would you mind posting that link in the chat?
Yeah, you mean this one?
Yeah.
Yeah.
I'll throw a link in here as well. That link and a few other things are on the engineering resources page. It's like the national page for, I don't know, all the guys we have right now. And I'll just post that here. It'll link out to that thing. It's what Bits of Good uses as well, the Georgia Tech chapter. But yeah, this page has some comments about commit messages. It's a really short little thing about how to format a nice commit message. And then I believe, yeah, at the right below it is the GitHub best practices stuff. And that is like pull requests, as you mentioned.